Hi, welcome to this video on finding the area of a triangle using coordinate geometry. The area of the triangle with vertices 0, 0, x1, y1 and x2, y2 is given by the formula area equals a half of x1 multiplied by y2 minus x2 multiplied by y1. This formula is found in your maths tables. The two vertical lines indicate that we take the positive value of the result, as area can never be negative. Let us have a look at our example. Find the area of the triangle with vertices 0, 0, minus 2, 1 and 3, 4. It's important to note that to use this formula, one of our vertices must be 0, 0. In this case it is. Therefore we can use our formula to find the area of this triangle with these vertices. Area is given by a half of x1 multiplied by y2 subtract x2 multiplied by y1. Our 2 points minus 2, 1 and 3, 4 is what we're going to use in our formula. x1, y1 and x2, y2. Filling our formula in, this gives us 1 half of x1, which is minus 2, by y2, which is 4. Subtract x2, which is 3, by y1, which is 1. This gives us negative 2 by 4 is minus 8. Negative 3 by 1 is negative 3, which gives us a half of minus 11. The two vertical lines indicate that we take the positive value, which gives us a half of 11, which is 5.5 or 5.5 square units. This is the area of the triangle with vertices 0, 0, minus 2, 1 and 3, 4. Pause the video here and take down this example into your notes copy. Let us look now at what happens when one of the vertices is not 0, 0. If you look at what we have here, we can see we have a triangle where none of the vertices is at the origin. I'm going to call it triangle 1. We find the image of the triangle under translation so that one of the vertices is 0, 0. So we say let 2, 4 map to 0, 0. Here we have taken 2 from the x value and taken 4 from the y value. Minus 2, minus 4. We must do the same to each other point. 7, 3 therefore becomes 5 minus 1. And 4, 1 maps to 2 minus 3. This now gives us the second triangle in the diagram. However, triangles 1 and 2 have the same area. Let us now have a look at an example where none of the vertices are at the origin. Example 2. Find the area of the triangle with vertices 2, 4, 3 minus 1 and 3 minus 5. The first thing we should notice here is that none of the vertices are at the origin. Therefore we must perform a translation. And we're going to let 2, 4 go to 0, 0. I've subtracted 2 from x and subtracted 4 from y. I must do the same to the other values, the other points. So 3 minus 1 goes to minus 5 minus 3, and 3 minus 5 goes to 1 minus 9. So now we have what we need in order to be able to fill in our formula. Our formula is the area of a triangle is equal to a half x1 y2 subtract x2 y1, and the points minus 5 minus 3 and 1 minus 9 are x1 y1 x2 y2. We can now fill our formula in. This gives us a half of x1, which is minus 5, by y2, which is minus 9, subtract x2, which is 1, by y1, which is minus 3. Negative 5 by negative 9 is positive 45. Minus 1 by negative 3 is positive 3, which gives us a half of 48, which equals 24 square units. This is the area of our triangle. Take this example down. Answer these questions. Question 1. Find the area of the triangle whose vertices are 0, 0, 2, 1, 3, 4. Part 2, 0, 0, 5, 1, 3, 6. Part 3, 0, 0, minus 2, 3, 1, minus 4. And part 4, 0, 0, 3, 4, minus 2, minus 6. Question 2. A is 2, 3, B is minus 5, 1, and C, 3, 1 are the vertices of a triangle. By using the translation A, 2, 3 maps to 0, 0, find the images of B and C under this translation. Hence, find the area of the triangle.